Hey there, space fans. Ready for another deep dive?
Always.
Awesome. Today, we're looking at how engineers design spacecraft for asteroid missions.
Oh, cool.
Yeah, we've got this chapter from a technical document, and it's pretty fascinating.
I bet. It's not just about spaceships and rockets, though, right?
No, definitely not.
It's a whole lot more.
It's about surviving in, like, the most extreme environments you can imagine.
Yeah, for sure.
Navigating those crazy, vast
Okay.
distances.
Yeah,
And then all this cutting-edge tech,
for sure.
mining, resource extraction,
Definitely.
even planetary defense.
So, like, interacting with these asteroids, not just looking at them.
Yeah, exactly. It's about like studying them and potentially even using those resources.
It's amazing to think about.
So before we get into like all the nuts and bolts of designing these spacecraft,
Okay.
let's take a step back.
Right here.
Why are we even interested in asteroids?
Good question.
What makes them so special?
Well, they're like time capsules, right?
Yeah.
From way back when the solar system was forming.
Oh, cool.
They've got these clues about how planets formed.
Oh, wow.
Could give us some crazy insights into how our own planet came to be.
That's awesome.
But it's more than just that, like the pure scientific curiosity.
Yeah, there's got to be more.
Asteroids have all this potential for resources.
Really?
Yeah, things we could actually use. Water, metals, even rare minerals that are hard to find here.
Wow. And then there's that whole planetary defense thing too.
Right.
Identifying and maybe even deflecting those asteroids that might,
Be a threat.
yeah, be a threat to us.
Like a cosmic trifecta.
Exactly. Scientific discovery, resources, and protecting our planet.
Yeah, that's why we send these missions.
No wonder we're sending spacecraft to check them out.
It's so cool.
But I imagine designing a spacecraft for an asteroid mission.
Uh-huh.
It's got to be totally different from, say, putting a satellite in orbit around Earth.
Oh, yeah, absolutely. The challenges are immense, just immense.
I can imagine.
Think about it. You're sending this thing millions of miles away, sometimes billions,
That's crazy far.
to this little, tiny, weirdly shaped object that's just zipping through space.
Yeah, like trying to park on a giant spinning potato.
Uh-huh. Yeah, kinda.
So where do you even start with something like that?
Well, the first thing is, what's the mission?
Okay, yeah.
What are we trying to do? Explore, look for resources, mine those resources, or even, deflect a potential threat.
Right.
Each of those is going to need a different kind of spacecraft.
Makes sense.
Like a mining mission would need heavy-duty tools and processing units,
Oh, yeah, I guess so.
while a defense mission might need systems to, like, nudge the asteroid off course.
That's wild.
It's about picking the right tool for the job, but on a cosmic scale, you know?
Yeah, okay, that makes sense. So let's say we're designing a spacecraft for a mining mission.
Okay.
Where do we begin?
With the spacecraft itself, the architecture, the materials, the shape, the overall structure has to be strong, lightweight, and able to survive,
In that space.
space, exactly.
So what kind of materials can handle a launch, traveling millions of miles, and then, like, working in a place with crazy temperatures and radiation? And don't forget those micrometeoroids.
Oh, yeah, those two.
Sounds like you need something tougher than a tank.
You're not wrong. We're talking super strong, lightweight stuff like carbon fiber.
Oh, wow, like race cars?
Yeah, and aluminum alloys for the structure. And for radiation, it's like wrapping the spacecraft in a high-tech blanket.
The blanket.
Yeah, to deflect harmful rays, kind of like a superhero's shield.
Right.
Materials like lead, tantalum, or high-density polymers.
So it's like a tiny space bunker for the electronics.
Yeah, to
Exactly.
keep them safe.
Protect them from all that radiation.
But what about temperature?
Oh, yeah, that's another big one.
It's going to get super hot near the sun and then freezing in the asteroid belt, right?
You got it. Asteroids go through these wild temperature swings.
Oh, wow.
So to keep everything inside working, the spacecraft needs a really good thermal control system.
Oh.
Insulation, like multi-layer blankets.
Oh, interesting.
Special radiators to get rid of heat.
Oh.
And clever ways to manage how heat flows, absorbing it where it's needed, getting rid of it elsewhere.
So it's like a super efficient heating and cooling system for your house,
Pretty much.
but in space.
But in space.
That's really cool. So we've got our super tough, climate-controlled spacecraft.
Right.
But how do we actually get it to an asteroid that's millions of miles away?
Now we're talking propulsion.
Okay, let's hear it.
Getting to an asteroid is kind of like planning a road trip across a bunch of countries.
I like that analogy.
You need the right vehicle for the journey, right?
Yeah, definitely.
And for this kind of trip, we've got a few options.
Lay 'em on me. What are our choices?
Well, there's the classic, the workhorse chemical propulsion.
Like rocket engines?
Yep, just like traditional rockets. They're great for launch and big orbital maneuvers.
All right.
Lots of thrust, but they use a lot of fuel.
Yeah.
Not ideal for those long hauls to the asteroid belt.
Uh.
So it's like using a gas-guzzling SUV for a cross-country road trip.
Haha, exactly. Not very fuel efficient.
What about the alternatives then? What are our options for saving fuel on those long trips?
It's electric propulsion.
Okay.
Things like ion thrusters or Hall effect thrusters.
Those names sound familiar.
They're like the super efficient electric cars of space travel.
Cool. But how do they work? Do we need to, like, plug them into a giant space outlet?
Haha, no, not quite. These systems use ionized gas, usually xenon, to make thrust.
Oh, okay.
And the great thing is they're incredibly efficient because they use way less fuel.
Oh, that makes sense.
And they can run for months, even years, continuously.
That's amazing.
Remember the Dawn spacecraft, the one that explored Vesta and Ceres?
Yeah, that one was all over the news.
That was a perfect example of how good ion propulsion can be for asteroid missions.
So it reached those asteroids farther and more efficiently, all with, what, like a supercharged ion beam?
That's a good way to put it.
That's incredible.
It really is.
What about solar sails? I've always thought those were so cool. Using sunlight to push a spacecraft?
Yeah, it sounds like science fiction, right?
Exactly.
But it's not just an idea anymore. Japan's space agency, JAXA, they launched a solar sail demonstrator called Icaros back in 2010.
Wow. So they're actually building these things.
They are, and they hold a lot of promise, especially for missions where fuel efficiency is super important, but they're still pretty early in development.
Okay.
The big challenge right now is the thrust from sunlight is really weak.
Oh, so it's like sailing a boat on a windless day.
Pretty much. You'll get there eventually, but it'll take a while.
Okay, I see. And then there's nuclear propulsion, which always seems to be a bit controversial.
Yeah.
What's the deal with that?
Nuclear propulsion is definitely another possibility, especially if we're going way out there, to the outer solar system or the asteroid belt where there's not much sunlight.
Oh, that makes sense.
It gives you a lot of power, and it's efficient, but of course there are safety and political issues.
Right.
Things that need to be carefully considered.
Of course. Of course. So it sounds like picking the right way to get to the asteroid is like picking a car for that road trip.
It is.
It depends on how far you're going, how fast you want to get there, and how much you want to spend on gas.
Exactly. Great analogy. But even with the perfect vehicle, you can't go anywhere without power.
Right. Yeah, power.
Out in space, you can't just plug into the grid,
So how do these spacecraft keep everything running?
Good question.
Seems like solar panels would be the obvious choice.
You'd think so, right?
Yeah.
And they're great if you're close to the sun.
Oh. What?
But further out, like in the asteroid belt, they get much less efficient.
Oh, I didn't think about that.
Yeah.
So what do you do then?
Yeah.
Just pack a bunch of extra batteries?
Batteries are part of it, yeah, especially for those quick bursts of power and when the spacecraft is in shadow.
Okay.
But for longer missions, especially out in the dark parts of the solar system, we need something else.
Something else.
Something a bit more nuclear. RTGs.
RTGs.
Radioisotope thermoelectric generators.
Okay. Those sound a little intimidating.
They might sound a little scary,
Yeah.
but they're amazing pieces of engineering.
Oh.
They use heat from radioactive decay to make electricity.
So, like, tiny nuclear power plants on the spacecraft.
Kind of.
I can see why people might be a bit nervous about that.
Yeah, there are definitely safety protocols in place.
Sure.
And the amount of radioactive material is really carefully controlled.
Okay, that's good to know.
But the benefits are huge.
Yeah.
Especially for those deep space missions.
Right, right.
They're really remarkable.
So it seems like you need a mix of power sources.
You do.
Solar panels when you're near the sun, RTGs for deep space, and batteries for backup and those short bursts of power.
Exactly.
Yeah.
Like a hybrid car for space.
I like it. But even with all that power, it's useless if you can't talk to Earth, right?
Absolutely. Communication is key.
So how do we stay in touch with these spacecraft when they're millions of miles away?
Well, it's tricky. It's like having a really, really long distance relationship.
With lots of lag.
Lots of lag. Dealing with signal delays and limited bandwidth, it's a challenge for sure.
So how do we do it?
The most common way is the Deep Space Network, or DSN.
The Deep Space Network.
Yeah, it's a network of these giant antennas
Wow.
located all around the world.
Right.
And they act like these cosmic phone lines,
Oh.
letting us send commands to the spacecraft
Okay.
and get data back.
Awesome. I can picture these huge dishes listening for faint whispers from across the solar system.
It's kind of like that.
But I imagine the signals get weaker the further away you are, right?
Yeah, definitely.
And there must be delays, those awkward pauses, like in a bad video call.
Oh, yeah, for sure. The further away the spacecraft is, the longer it takes for signals to go back and forth.
So the mission controllers have to be really careful with their commands
Oh,
and account for those delays.
definitely. They're basically playing a cosmic game of chess.
I love that.
They gotta think several moves ahead.
That's incredible.
Hmm.
Are there ways to, like, reduce those delays or increase the bandwidth? It seems like it would be hard to get all that data back, especially with all the high-res images.
Yeah, it is. One way is to compress the data.
Oh, okay, like zipping a file on your computer?
Exactly. Make it smaller, faster to send. But we're also developing more advanced stuff like autonomous communication systems.
What's that?
So the spacecraft can relay data on its own.
Oh, cool.
It doesn't have to wait for instructions from Earth.
So give it a little independence.
Yeah, let it make some decisions about when to send stuff back.
That's a good idea. What about using lasers?
Oh, you mean optical communication?
Yeah.
That's a game changer.
Right.
It uses lasers instead of radio waves.
Oh, wow.
And it can transmit way more data way faster.
That's awesome.
It's like upgrading from dial-up to fiber optic internet.
Oh, I get it. But I bet it's tough to aim a laser beam at a tiny spacecraft millions of miles away.
It is. It's like trying to hit a bullseye on a dime from across the country.
Yeah, all right.
But the payoff is huge, so we're working on it.
Yeah, I bet. It's amazing to think about all the technology and brain power that goes into just staying in touch with these spacecraft.
It's incredible.
So we've talked about structures, propulsion, power, communication,
Yeah.
but how do these spacecraft actually find those tiny asteroids?
Yeah.
And how do they, like, land on them or get close enough to study them?
Well, it's not like there's a GPS out in space.
Definitely not.
And asteroids are moving targets, constantly tumbling, and with very weak gravity.
So how do they do it?
It comes down to autonomous navigation.
Okay.
Spacecraft use a few different techniques to find their way. They use cameras to take pictures of the stars
Oh, okay.
and use those as reference points, like celestial landmarks.
That's pretty cool.
And they use LiDAR, which is kind of like radar but with lasers,
Oh, okay.
to measure distances and create detailed 3D maps.
So it's like giving this spacecraft a sense of sight and touch, right?
Yeah, exactly. So they can map their surroundings and figure out where they're going.
That's incredible. But what about getting up close to the asteroid? Do they actually land or just orbit around it?
It depends on the mission.
Oh, okay.
Some missions, like Japan's Hayabusa 2, are designed to collect samples from the surface,
Oh, wow.
which takes some really specialized equipment.
I can only imagine. Landing on an asteroid with its weak gravity and crazy shape?
Oh, yeah, it's not like landing on the moon.
No, definitely not.
It's more like docking with a giant spinning space potato.
Okay, that does sound tricky.
It is, and that's why engineers have come up with all these brilliant solutions to keep the spacecraft stable during those surface operations.
Like what? How do they keep them from bouncing off into space?
Well, sometimes they use thrusters to gently lower the spacecraft down.
Oh, like a jetpack.
Exactly.
Cool.
Other times they use harpoons or anchors to attach themselves.
Harpoons? Seriously?
Seriously. Almost like a rock climber using pitons.
That's wild.
And sometimes they even use tethers to connect the spacecraft to a larger platform that's orbiting the asteroid.
So it's like a cosmic high wire act.
You got it. All these techniques to help them stay grounded.
That's amazing.
Yeah.
What about interacting with the asteroid surface?
You mean actually touching it and doing stuff?
Yeah.
That's where the payload comes in.
Okay.
It's the heart of any mission.
Okay.
It's the equipment that does the work.
The work. Okay.
Whether it's scientific instruments for studying the asteroid or mining tools for getting resources,
Yeah.
it's like the mission's toolbox.
So what kind of tools are in this cosmic toolbox?
Well, for science missions, you've got things like spectrometers
Okay.
to analyze what the asteroid is made of, cameras to take pictures,
Of course.
and magnetometers to measure magnetic fields.
What do those tell us?
They can tell us about the asteroid's internal structure.
Oh, cool. So it's like giving the spacecraft senses
Yeah,
to observe and understand the asteroid.
exactly.
What about for mining?
Oh, that's when we bring out the big guns.
Uh-huh. Okay.
Drills, grinders to break up the surface material, and then regolith collectors to gather it up.
Regolith.
It's the loose stuff on the surface,
Oh, okay.
but it's not just about getting the materials.
Right.
You got to process them too.
So some missions might even have like miniature refineries.
Exactly.
That's mind-blowing.
To extract the valuable stuff right there on the asteroid.
That's incredible. It's like setting up a tiny factory on an asteroid.
Pretty much.
But I bet there are some serious challenges to making all this work in space.
Oh, for sure.
It's not exactly a friendly environment.
No, it's not.
So designing and operating these systems out there,
Yeah.
that's got to be one of the biggest hurdles, right?
Absolutely. Designing something to work here on Earth is one thing,
Right.
but making it work reliably millions of miles away in space, that's where the real engineering magic happens.
I can imagine.
And that's a perfect place to pause and let our listeners absorb everything we've covered so far.
Yeah, we've talked about a lot. The structure of the spacecraft, how they get around, and they stay powered up, and how they communicate with Earth.
We've covered a lot of ground.
Harpoons, anchors, lasers, miniature refineries on asteroids.
Yeah.
It's been quite a ride.
For sure. But we're just getting started.
Stay tuned, everyone, because when we come back, we're diving even deeper into the world of asteroid mission design. We'll explore the unique challenges and ingenious solutions that make these missions possible.
It's going to be fascinating.
We will be right back. Welcome back, everyone. Before the break, we were talking about some pretty mind-blowing stuff like miniature refineries on asteroids.
Yeah, setting up shop on an asteroid.
It's incredible.
Yeah.
But I bet trying to run those things in space comes with some unique challenges.
Oh, absolutely. Designing these systems to work here on Earth is hard enough.
Yeah.
But making them work millions of miles away in the harsh environment of space, that's a whole other level of engineering.
So let's talk challenges. What are some of the biggest hurdles for these missions?
Well, low gravity is a big one.
Ah, right. Asteroids don't have much gravity.
Makes landing and moving around really tricky. It's not like the moon with its stable gravity.
Yeah, you can't just take a stroll on an asteroid.
Asteroids are so much smaller, their gravity is super back. It'd be like trying to walk on a giant bouncy ball.
One small step for man, one giant leap back into space.
Pretty much.
So how do they keep the spacecraft from bouncing off into the void?
Clever engineering, of course.
I figured.
Some missions use thrusters to gently lower the spacecraft onto the surface.
Like a little jetpack.
Exactly.
Neat.
Others use harpoons or anchors to attach themselves.
Wait, harpoons? Like for whales?
Well, not exactly, but the principle is the same. They shoot out these harpoons to grab onto the surface.
Wow, that's wild.
And sometimes they use tethers to connect the spacecraft to a bigger platform that's in orbit.
So it's like a cosmic safety line.
Exactly. All these techniques to make sure the spacecraft stays put.
Incredible. What other challenges are there?
Well, think about the shape of asteroids.
They're not exactly smooth and round.
Nope, they're lumpy and bumpy, and they spin in unpredictable ways.
That's got to make landing tricky.
It does. It's more like trying to park on a giant spinning potato in zero gravity.
Okay, I'm starting to see why they call it rocket science.
Yeah, you're not wrong.
So how do they even plan for that?
Lots of math and really smart people.
Of course.
They develop these sophisticated algorithms for dynamic modeling and adaptive navigation.
What does that even mean?
Basically, the spacecraft has to be able to sense its surroundings and adjust its trajectory in real time.
So it can dodge obstacles and make sure it lands safely.
Exactly. It's like a self-driving car, but for asteroids.
Cool. And then on top of all that, you've got the harsh environment of space itself.
Oh yeah, space is not a friendly place.
Definitely not a vacation destination.
We're talking extreme temperatures, intense radiation, and micrometeoroids whizzing around at crazy speeds.
It's enough to make you want to stay home.
It's a tough place to be, that's for sure.
So how do they protect the spacecraft and all its sensitive instruments from that?
Think of it like a suit of armor, layers of protection.
Okay.
They use radiation shielding to block those harmful rays.
Makes sense.
They use hardened electronics that can withstand the radiation.
Oh, cool.
And protective coatings to deflect those micrometeoroids.
Like a tiny spaceship shield.
It's kind of like sending a knight into battle, but instead of swords and arrows, it's cosmic rays and space rocks.
That's an awesome analogy. But with all these challenges and the huge distances involved, these missions must require a lot of autonomy.
Oh, definitely. You can't just call up the spacecraft and ask for help if something goes wrong.
No tech support hotline in space.
Nope.
And remember those communication delays we talked about? They make real-time control pretty much impossible.
It'd be like trying to play a video game with a lag so bad you'd just give up.
Yeah, that's frustrating.
Uh,
So the spacecraft has to think for itself.
It does, to a certain extent. It needs to make decisions and carry out complex tasks without humans stepping in.
That's a lot of responsibility.
It is, and that's where artificial intelligence comes into play.
Oh, right, AI.
Engineers are developing some really sophisticated algorithms.
Oh, cool.
They allow the spacecraft to navigate, collect samples, and even respond to unexpected situations all on its own.
So it's like a little robot brain controlling the spacecraft.
It's a good way to put it.
Incredible. It's like something straight out of a science fiction movie.
It kind of is, but it's becoming more and more real.
That's amazing.
Yeah.
So let's talk about the future of asteroid mission design. What are some of the exciting things on the horizon?
Oh, there are some really mind-blowing ideas being explored.
Okay, give me the good stuff.
One of the most promising is modular spacecraft.
Modular spacecraft. What's that?
Imagine a spacecraft that's like a Lego set.
Okay.
You can swap out parts, upgrade systems, or even add new modules while the mission is going on.
So it's adaptable, it can change depending on what it needs to do.
Exactly, like giving the spacecraft its own toolbox and letting it tinker with itself.
I love that idea. What else is in the pipeline?
Swarm robotics is another exciting area.
Swarm robot,
It's about sending multiple small robots to work together as a team.
like a team of tiny explorers.
Exactly. Instead of one big spacecraft, you have a swarm of smaller ones.
What's the advantage of that?
Well, they can cover more ground and do more complicated tasks.
That makes sense.
And because they're smaller and simpler, they're cheaper and faster to build.
It's more efficient and cost-effective.
Exactly.
What are futuristic ideas that they're working on?
How about 3D printing in space?
Whoa, you mean like building things on an asteroid itself?
Yep. Using the materials that are already there.
So you wouldn't have to bring everything from Earth.
Exactly. It would revolutionize space exploration.
That's mind-blowing. So we could have 3D printers making habitats and equipment right there on the asteroid.
It's not science fiction anymore. It's becoming reality.
That's incredible. What else?
Well, another area with a lot of potential is energy harvesting.
Energy harvest.
Finding ways to get power from the space environment itself.
Oh, interesting. Like space solar panels.
Sort of. Think about using huge reflectors to focus sunlight onto solar panels, or
Okay.
tapping into the heat energy of an asteroid itself.
So you're using the resources that are already out there to make the mission more self-sufficient.
Exactly. It's all about sustainability.
That's really smart.
And remember, all these advancements wouldn't be possible without the missions that came before.
Right, those pioneers that paved the way.
They laid the foundation for everything we're doing now.
Speaking of pioneers, let's talk about some of the most successful asteroid missions so far.
Oh, there have been some amazing ones.
What are some that really stand out?
Well, you can't talk about asteroid missions without mentioning Japan's Hayabusa and Hayabusa 2 missions.
Yeah, those were big news when they brought back those samples.
They were incredible feats of engineering. They used ion propulsion, autonomous navigation, and some really innovative sample collection techniques.
What do they do?
Well, they actually shot a projectile at the asteroid to create a small crater and then collected samples from the material that was ejected.
Wow, that's thinking outside the box.
It was brilliant.
What other missions have made big contributions?
NASA's OSIRIS-REx mission was another success story. It brought back a sample from asteroid Bennu in 2023.
Oh, yeah, I remember that one. What was special about that mission?
It used a robotic arm with a special sampler head to gently touch the surface of the asteroid and scoop up some regolith.
So we actually have pieces of an asteroid here on Earth now.
We do, and scientists are learning a lot from them.
That's so cool. What other missions come to mind?
Well, NASA's Dawn mission was a real pioneer. It used ion propulsion to orbit and study Vesta and Ceres, the two largest objects in the asteroid belt.
So it spent years studying those asteroids up close.
It did. It sent back amazing pictures and a ton of data.
These missions are incredible.
They are. They show what we can achieve when we push the boundaries of what's possible.
With all the advancements we've talked about, modular spacecraft, swarm robotics, 3D printing in space, energy harvesting,
Yeah.
the future of asteroid exploration looks incredibly bright.
It does. We're at the start of a new era of space exploration, and asteroids are right at the center of it.
It's an exciting time to be following all this. So with all these advancements, what do you think the future holds?
That's a great question, and it leads us perfectly to the final part of our deep dive.
Ooh, a cliffhanger.
When we come back, we'll wrap things up and leave you with something to think about.
Okay, everyone, stay tuned. We'll be right back. Welcome back, everyone. We've covered a lot of ground in this deep dive into asteroid mission design. From the nitty-gritty of spacecraft design to those mind-boggling challenges of actually operating in space.
It's been a wild ride for sure.
We've talked about everything from harpoons and anchors to lasers and even 3D printers building things on asteroids.
It's amazing what engineers are doing these days.
It really is. What really strikes me is just how ingenious and determined these engineers are.
Oh, absolutely.
They're tackling problems that would have seemed impossible not that long ago.
I know, right?
Building spacecraft that can travel millions of miles, work all on their own in these crazy environments,
Yeah.
and do these super precise tasks. It's inspiring.
It really is. It shows you what humans can do when we set our minds to something.
It's a testament to human ingenuity and our desire to explore the unknown, like you were saying earlier.
For sure. And it's not just about the technology itself.
All right.
It's about collaboration.
Yeah, I see that.
Scientists, engineers, mathematicians, programmers, all these people working together
Combining their expertise.
to make these crazy ideas a reality.
Exactly. And as we talked about, the future of asteroid mission design is full of possibilities.
Oh, yeah. The future's looking bright.
Modular spacecraft, swarms of robots, 3D printing in space, energy harvesting.
It's mind-blowing.
It's a future that's both awesome and a little intimidating, to be honest.
I know what you mean. It could change everything.
So as we wrap up, I have one final question for you.
Okay, shoot.
We've talked about all these amazing advancements, but what role do you think asteroid exploration and using those resources will play in shaping humanity's future?
That's the big question, isn't it?
It is.
Will we become a multiplanetary species? Will we use those resources to build a better future? Or will we run into new problems, new ethical dilemmas as we go further out into space?
It's something to think about.
It is. It's a really profound question.
Only time will tell.
I guess so.
But one thing's for sure, our drive to explore, to learn, to push the limits, that's not going away.
That's part of what makes us human.
Exactly. And who knows what we'll find out there.
It's an exciting time.
It is. So on that note, we'll leave you to ponder the possibilities.
Happy exploring.
Thanks for joining us on this deep dive into the fascinating world of asteroid mission design. Until next time, keep looking up and keep exploring.